Today's video is on complemented lattice and this is related to the discrete mathematics. So in today's video I am going to explain what is a complemented lattice. See here, if L join meet 0, 1 is a bounded lattice. See here, it's a bounded lattice. Here if you observe, so 1 is the greatest element and 0 is the least element, and L is said to be the bounded lattice. So an element A belongs to a lattice, then the element B belongs to L is called the complement of A if two relations hold, that is A join B is equal to 1 and A meet B is equal to 0. See here, it's so simple. L is a lattice and here are the relations, that is join and meet, and 0 is the least element and 1 is the greatest element. As lattice L is bounded between these two elements, it is called a bounded lattice. If we take an element A belongs to L, then the element B belongs to L is called a complement of A if A join B is equal to 1 and A meet B is equal to 0. See here, a lattice L join meet 0, 1 is called a complemented lattice if every element of L has at least one complement. If each and every element has at least one complement, then we say that the given lattice is a complemented lattice. It is so simple that A join B should be equal to the greatest element and A meet B should be equal to the least element. And using this definition, we are going to solve a problem here. So consider the bounded lattice, that is D20, and here the relation is divisibility. From the hash diagram, check whether it is a complemented lattice or not. So which lattice it is? Complemented. So whether it is a complemented lattice or not, so we have to check. So coming to the point here, so D20, so these are all the divisors of 20. So 1 divides 20, 2 divides 20, 4, 5, 10 and 20. These are all the divisors of 20. So we have to frame a hash diagram using the relation divisibility. So 1 is the least element. So I am starting with this. So 1 divides 2, whereas 1 divides 5 and 5 divides 10. 2 divides 4 as well as 10. So there is an edge between 2 and 10. So there is no edge between 2 and 5 as there is no relation, divisibility relation between 2 and 5. And so here, if you observe, this one, then 4 divides 20. So here if you see, 2 also divides 20. See here, 1 divides 2, 2 divides 4, and next 4 divides 20, and here 5 divides 10. So 1 divides 5 and 1 divides 2. So this is the hash diagram. Using this hash diagram, so here the greatest element is 20 and the least element is 1. So next, coming to the point here, so we have to find whether each and every element possesses a complement or not. If each element possesses at least one complement, then we say that the given lattice is a complemented lattice. And for that, let's get started to solve this. So D, so what is here? There is a relation, divisibility relation. So these are all the divisors of 20. So the divisors of 20 are 1, 2, 4, 5, 10 and 20. So if you observe this one, so this is the hash diagram. So using this hash diagram, see here 20 also divides. So 2 also divides 20 here. So let's get started to solve this. So here if you observe, for finding a complement, so we have a relation, that is A join B is equal to the greatest element here is 20 and A meet B should be equal to the least element here is 1. So if this condition holds, then we say that the complement of A is equal to B. So let's get started. So here join and here is the meet. So join, as these are numerals, we can take the LCM. For join, we can consider the least common multiple of this. And here for meet, it is the GCD, the greatest common divisor, or the greatest lower bound from the hash diagram. So from the hash diagram, it is the least upper bound here. So let's get started to find out for each and every element. So for 1 and 1 is an upper bound. So for 1 and 2, this is 2 is the upper bound. See here, for for next one 1 and 4. So this is 1 and 4. 4 is the upper bound. So for 1 5. So this is 1 and 5. 5 is the upper bound. So for 1 and 10. See here for 1 and 10. 10 is an upper bound. So for 1 and 20. So the greatest element here is 20. 20 is an upper bound. And coming to 2 and 1. See between 2 and 1. 2 is the upper bound here. For 2 and 2, 2 is an upper bound. For 2 and 4, so which one is an upper bound? 4 is an upper bound. For 2 and 5, so 2 and 5, first they meet at a point. For 2 and 5, they meet at a point 10 here. So this is 10. For 2 and, so this one, for 2 and 10, 10 is the upper bound. For next one, for 2 and 20. So this is 2 and 20. What is an upper bound here? So this one is nothing but 20. So this is 20 here. And next coming to 4 and 1. So among 4 and 1, what is the upper bound here? So upper bound is nothing but 4. Among 4 and 2, 4 and 2, 4 is the upper bound. So 4 and 4, 4 will be the upper bound. 4 and 5. So there is 4 and there is 5. So they both meet at a point 20. So here they meet at a point 20. And next one 4 and 10. So again 4 and 10 they meet at a point here 20. And next 4 and 20. So here is 4 and 20. 20 is an upper bound. And next one among 5 and 1. Among 5 and 1, 5 is the upper bound. That is least upper bound. So 5 and 2. Coming to 5 and 2. So the upper bound here is 10. The upper bound here is 10. And the next one coming to 5 4. Among 5 and 4 they meet at a point. See here among 5 and 4 they meet at a point 20. So 20. And next one among 5 and 5. 5 is a upper bound. Among 5 and 10. 5 and 10. 10 is an upper bound. And among 5 and 20. Among 5 and 20. 20 is the upper bound. And next 10 1. So this is 10 and 1. 10 is the upper bound. See here 10 is an upper bound. Among 10 and 2. So 10 and 2. 10 is an upper bound. And among 10 and 4. Among 10 and 4. See here the upper bound here is 20. So this is a 20. And next one among 10 and 5. 10 and 5, 10 is an upper bound. Among 10 and 10, 10 is an upper bound. Among 10, 20. So this is 10 and 20. 20 is the upper bound. And next among 20 and 1. As you know that 20 is the greatest elements among all these. So I am writing 20 here. See here among 20 and 1, 20 is the greatest element. Here also 20 will be the greatest element among all these elements. And here coming to the least element here. So this is the greatest lower bound. So among 1 and 1, 1 will be the lower bound. Here 1 is lower bound, 1 is lower bound, 1, everything here is 1. As you see from the hash diagram. See here among 2 and 1. So among 2 and 1, 2 and 1, so 1 is the lower bound. Among 2 and 2, 2 is the lower bound. Among 2 and 4, so we have the 2 is a lower bound. Among 2 and 5, so this is 2 and 5, the lower bound here is 1. Among 2 and 10, so among this 2 and 10, the lower bound here is among 2 and 10, the lower bound here is 2, and among 2 and 20, so this is 2 and 20, the 20 is the, lower bound here is 2, the lower bound here is 2. Among 4 and 1, so among 4 and 1, 1 is the lower bound. Among 4 and 2, 2 is the lower bound. Among 4 and 4, 4 is the lower bound. Among 4 and 5, see here, they meet at a point 1 here. First, they meet at a point 1 here. 4 and 10, so they meet at a point 2 here. Or else take the GCD of two elements. It is very easy. 4 and 5, the greatest common factor. See for 4 and 20, among 4 and 20, the greatest So among the least element here, the greatest element here is 4. So this is 4. Among 5 and 1, see here, this is 5 and 1. See here, the greatest lower bound here is 1. Among 5 and 2, the lower bound here is 1. And among 4 and 5, so 4 and 5, they meet at a point 1 here. Lower bound is 1. And among 5 and 5, next, the greatest lower bound is 5. Among 5 and 10, so this is 5 and 10, the lower bound here is 5. Among 5 and 20, so this is 5 and 20, and the lower bound is 5. And coming to 10, 1, so 10 and 1, so this is 10 and 1, the lower bound here is 1. And next coming to 10, 2, so this is 10 and 2, the lower bound is 1. And next 10 and 4, so among 10 and 4, they meet at a point. So here they meet at a point 2. So here they meet at a point 2. And next one, and coming to 10 and 5, so this is 10 and 5, the lower bound here is 5. And next coming to 10, 10, here the lower bound is 10, 10 and 20. Among 10 and 20, 20 is the 10 is the lower bound. Next 20 and 1. So among 1 and 20, so 1 is the lower bound here. And next 22, 22 is the least. And next 20 and 4. Among 20 and 4, this 4 is the greatest lower bound. Among 25, so this is 20 and 5, 5 is the greatest lower bound. And among 20 and 10, 20 and 10, 10 is the greatest lower bound. And 20 and 20, 20 is the lower bound here. So if you see the greatest, see here, so here is the upper bounds here, that is the least upper bound here is 20, or the greatest element here. So the least element is here. And next coming to this, so here we have the greatest element, whereas the least element doesn't match here. See, so there is a problem with 2. So we have the complement of 1. And next coming to 4, see here the fourth position, the greatest element is here and the least element is here. And coming to 5, so we have the greatest element here and the least element here. And coming to 10, here is the greatest element and here is, there is no least element here. So this 10 doesn't have a complement. And coming to 20, so we have a complement here, whereas the greatest element and the least element. See here, there is a problem with 2. So there is a problem with 2 and problem with 10 here. As see here, it doesn't. So 10 meet 4 doesn't equal to the least element. Here the least element is 1 here. And coming to this, here is the greatest element, whereas here there is a 2 here. So see here, there is a problem with 2 here. So there is a problem with 2 and 2 here. So therefore we say that there is no complement for 2 as well as 10, because see here the complement of 1 is equal to 20 here, as 1 join 20 is equal to the greatest element and 1 made 20 is equal to the least element. See here, 1 join 20 is equal to 20 and 1 made 20 is equal to 1. Whereas coming to 2, so here coming to 2, here 2 join 20 is equal to the greatest element, it's okay. But 2 meet 20 is doesn't equal to the least element 1 here. Therefore the complement of 2 doesn't exist. Coming to complement 4. So coming to complement 4, the complement of 4 is equal to 5, as 4 join 5 is equal to the greatest element and 4 meet 5 is equal to the least element. See here, 4 join 5 equal to 20 and 4 meet 5 is equal to the least element. Therefore the complement of 4 is equal to 5. And coming to 5 here, the complement of 5 is equal to 4, and here the complement of 5 is equal to 4, as 5 join 4 is equal to 20, greatest element, and 5 meet 4 is equal to 1, the least element here. And coming to 10 here, see here, it doesn't match with the least element as we have 2 here. Therefore 10, the element 10 does not have a complement. The element 2 does not have a complement, whereas 20, see here the greatest element here. So the complement of 20 is equal to 1, whereas the complement of 20 is equal to 1. So these satisfy. The complement of 5 is equal to 4 from the composition table, and the complement of 10 doesn't exist. And coming to complement of 20, the complement of 20 is nothing but 1, as it satisfies 20 join 1 is equal to, so 20 join 1 is equal to the greatest element, and 20 meet 1 is equal to 1. So these are all the complements where the complement of 2 and complement of 10 doesn't exist. Therefore, if each and every element has a complement, then we say that it is a complemented lattice. If at least one element doesn't have a complement, then we say that it is not a complemented lattice. See here, this is not a complemented lattice. So this is how we have to solve, and if you write this composition table, clearly we'll get an idea that. So if you don't know how to see from the hash diagram, so take out the LCM and GCD of these two, and definitely you can solve by your own. And if you really like, what to do, please share it with your friends, pass it on, and please subscribe to this channel, go through the playlist, and there are so many problem solutions are there, and please practice, and definitely you'll score more. Thank you so much.